Whereas diameter of the Pelton wheel, we need to consider some of the values. So Pelton wheel works efficiently, whereas diameter of the jet is small d. Diameter of the jet, whereas small d. Diameter of the wheel, capital D. The width of the bucket 5 into d, whereas 5 into diameter of the jet. The depth of the buckets 1.2 into d, and number of buckets on the wheel. Whereas size of the bucket means width and depth of the buckets, where we can see that a Pelton wheel designed for a head of 60 meters when we having 200 rpm. 200 rpm is n revolution per minute. The Pelton wheel develops 95.6475 kilowatts power. The velocity of the bucket is 0.45 times the velocity of the jet. Velocity of jet kante velocity of bucket ane 0.45 times ekkuva. Whereas overall efficiency is 0.85. Coefficient of the velocity is 0.98. They given that head 60 meters. Speed n is equal to 200 rpm. Soft power 95.647 kilowatt. Whereas velocity of the bucket u is equal to 0.45 is velocity of the jet is the given condition. Velocity of bucket is equal to 0.45 into velocity of jet. Overall efficiency 0.85. Coefficient of the velocity 0.98. Design of the Pelton wheel means to find the diameter of the D, capital D, and width of the depth of the buckets and number of buckets on the wheel. Design of Pelton wheel means diameter of jet kanukovali, diameter of wheel find out cheyali, width and depth of the buckets and number of buckets on the wheel kuda find out cheyali. Whereas velocity of the jet, we can see that V1 is equal to CV into root 2GH, 0.98 is given, 2 into 9.81 into 60 mm head is given, 33.62 meter per second. Whereas bucket velocity, we can see that U is equal to U1 is equal to U2. The given condition in case of Pelton wheel, U1 is equal to U2. The given condition 0.45 into V1 nothing but 33.62. We got it as 15.13 meter per second. Whereas U is equal to pi d n by 60, we can find it of capital D. Capital D is equal to 60 into 15.13 by pi into 200. Whereas 1.44 meters. Whereas capital D is 1.44 meter. Whereas diameter of the jet, small d, we need to find out. First of all, we go for the overall efficiency 0.85, and overall efficiency nothing but soft power by water power. Soft power they given 95.46475. Water power they given water power by 1000. Whereas 95.45 is 475 into 1000 by rho z qh. Water power nothing but rho into z into q into h. They substituted rho value 1000, density 9.81, gravity q we need to find out, h 60 they given. We got it as overall efficiency is equal to some value, whereas if you keep q one side and send everything other side of the equals, we got it as 0.1912 meter cube per second. You can observe that the q value meter cube per second, you need to remember meter cube per second discharge, but the discharge q is equal to area of the jet and velocity of jet, whereas pi by 4 d square into v1, pi by 4 d square into v1 we find out, d we need to find out that d value we got it as 85 mm. Whereas size of the buckets 5 into d, 5 into 85, 425 mm. Whereas depth of the bucket 1.2 into d, 1.2 into 85, 102 mm. Number of bucket we already seen that z is equal to 15 plus capital D by 2 into small d, 1.44 they came, 2 into 0.85, nothing but 23.5, we can say that we cannot keep half of the bucket. So we can say that 24 buckets we can keep for the good functionality of the Pelton wheel. Whereas radial flow reaction turbine in which water flows in the radial direction. The water flow may be radial from outwards to inwards towards the axis of the rotation. Radial flow reaction turbine, the water is flow inward radially from outsides to inwards, అంటే బయట నుంచి లోపలికి రేడియల్గా ఎంటర్ అవుతుంది, and from inwards to outwards. The water flows from outwards to inwards through the runner is called, the turbine is called inward radial flow turbine. బయట నుంచి లోపలికి వచ్చినప్పుడు ఇన్వర్డ్ రేడియల్ ఫ్లో, రేడియల్గా అవుట్ నుంచి ఇన్కి వచ్చినప్పుడు రేడియల్ ఫ్లో టర్బైన్. whereas water flows from inward to outward, the turbine is outward radial flow turbine. Whereas reaction turbine means water at the inlet of the turbine is possess kinetic energy and pressure energy. Reaction turbine అంటే kinetic energy ఉంటుంది, pressure energy ఇన్లెట్లో ఉంటుంది. బట్ ఇన్ కేస్ ఆఫ్ ఇంపల్స్ టర్బైన్ ఓన్లీ kinetic energy అనేది ఇన్లెట్లో ఉంటుంది, అవుట్లెట్లో కూడా kinetic energy ఉంటుంది. మెయింటైన్స్ ది ప్రెజర్ atmosphere pressure at inlet and outlet. In case of reaction turbine, we possess kinetic energy and pressure energy at the inlet as water flows through the runner as a part of the pressure energy. ప్రెజర్ ఎనర్జీ అనేది ఎలా కన్వర్ట్ అవుతుంది, టోటల్ కైనెటిక్ ఎనర్జీగా కన్వర్ట్ అవుతుంది. ఇన్లెట్లో మనకి ఏముంది, ప్రెజర్ ఎనర్జీ కైనెటిక్ ఎనర్జీ, బట్ అవుట్లెట్లో టోటల్ ప్రెజర్ ఎనర్జీ అండ్ కైనెటిక్ ఎనర్జీ అండ్ కన్వర్టెడ్ టు ది కైనెటిక్ ఎనర్జీ. ద మెయిన్ పార్ట్స్ ఆఫ్ the casing is air tight casing so that no water bubbles ఉండవు. సో ప్రెజర్ ఎనర్జీ అనేది ఇన్లెట్లో నుండి కైనెటిక్ ఎనర్జీగా చేంజ్ అవ్వడానికి యూజ్ అవుతుంది ఎయిర్ టైట్ కేసింగ్ వల్ల. ద మెయిన్ పార్ట్స్ కేసింగ్, గైడ్ మెకానిజం, రన్నర్, డ్రాఫ్ట్ ట్యూబ్. డ్రాఫ్ట్ ట్యూబ్ ఈజ్ వన్ ఆఫ్ ది మెయిన్ ఇంపార్టెంట్ పార్ట్ ఇన్ ది టర్బైన్.
Radial flow turbine. Fixed guide wheel, spiral casing, runner, water from penstock. In radial flow turbine, the water enters the runner in radial direction.
Water is inletting radially and airtight casing, so no air is present inside the casing. Casing, the water from the penstock enters the casing. It's spiral shape in which area of cross section casing goes on decreases gradually. The case completely surrounds the runner of the turbine, and the casing made of spiral shape, and so that the water may enter into the runner at the కాన్స్టెంట్ వెలాసిటీ. ఎందుకు స్పైరల్ షేప్లో పెట్టారంటే వెలాసిటీ ఆఫ్ ది వాటర్ అనేది కాన్స్టెంట్గా వెళ్తుందని. ద సర్కంఫరెన్స్ ఆఫ్ ది రన్నర్, త్రూ అవుట్ ది సర్కంఫరెన్స్ ఆఫ్ ది రన్నర్, ఒకేసారి సర్కంఫరెన్స్లో వాటర్ అనేది కాన్స్టెంట్గా వెళ్తుంది కాబట్టి. ద కేస్ ఈజ్ మేడ్ ఆఫ్ కాంక్రీట్, కేస్ స్టీల్ ఆర్ ప్లేట్ స్టీల్. గైడ్ మెకానిజం, వేరే స్టేషనరీ సర్క్యులర్ వీల్ ఉంటుంది అరౌండ్ ది రన్నర్ ఆఫ్ ది టర్బైన్. ద స్టేషనరీ గైడ్స్ veins are fixed on the guide mechanism. Guide mechanism ki fix ayi untai. The guide vanes, velocity of water strike the vanes on fixed runner without shock inlet. Also suitable arrangements. The guide vanes ఏం చేస్తాయంటే వాటర్ని లోపలికి పంపిస్తాయి వితౌట్ షాకింగ్. వచ్చిన వాటర్ అనేది షాక్ అంటే సడన్ ఇంపాక్ట్స్ ఇవ్వకుండా గ్రాడ్యువల్గా మూవ్ అయ్యేటట్టు, కాన్స్టెంట్ వెలాసిటీతో మూవ్ అయ్యేటట్టు చేసుకుంటాయి. ఓకేనా. విడ్త్ బిట్వీన్ టూ ఎడ్జెంట్ వేన్స్ ఆఫ్ ది గైడ్ మెకానిజం కెన్ బి ఆల్టర్డ్. విడ్త్ అనేది ఆల్టర్ చేసుకుంటారు, ఇక్కడ విడ్త్ సేమ్ ఉండదు. సో దట్ ది అమౌంట్ ఆఫ్ వాటర్ స్ట్రైకింగ్ రన్నర్ క్యాన్ బి వేరీడ్. వాటర్ స్ట్రైకింగ్ ది రన్నర్ వ్యారీ అవుతూ ఉంటుంది మనం విడ్త్ చేంజ్ చేస్తే. యూ కెన్ సీ దట్ రన్నర్ వీలర్స్ సిరీస్ ఆఫ్ రేడియల్ కర్వ్డ్ వేన్స్ ఆర్ ఫిక్స్డ్ ఉంటాయి. కర్వ్డ్ వేన్స్ అనేవి ఫిక్స్డ్ ఉంటాయి. ద సర్ఫేస్ ఆఫ్ ది వేన్స్ ఆర్ వెరీ స్మూత్. ద రేడియల్ కర్వ్స్ ఆర్ సో షేప్డ్ the water leaves the runner without shock. Curved veins అనేవి without shock అవుట్ వస్తుంది. The runners are made of cast steel, cast iron, స్టెయిన్లెస్ స్టీల్. దేర్ ఆర్ కీ టు ది షాఫ్ట్కి కనెక్ట్ చేసి ఉంటాయి. Draft tube at exit of the runner of the reaction turbine is less than the atmosphere. In case of atmosphere తక్కువ ఉందనుకోండి, వాటర్ అనేది రివర్స్లో ఎంటర్ అవుతుంది టర్బైన్లోకి. సో టు మెయింటైన్ దట్ డ్రాఫ్ట్ ట్యూబ్ అనేది యూజ్ చేస్తాం. ద వాటర్ ఎగ్జిట్ కెనాట్ డైరెక్ట్లీ డిశ్చార్జ్ టు ది టెయిల్ రేస్లో డైరెక్ట్గా డిశ్చార్జ్ చేయకుండా మధ్యలో డ్రాఫ్ట్ ట్యూబ్ అనేది ఫిక్స్ చేస్తాం ఎక్కడ టర్బైన్ అవుట్లెట్కి and tail race ki. A tube or pipe of gradually increased area is used for discharging water from exit of the turbine to the tail race. A tube or pipe of gradually increasing area, pipe anedi increasing area, pipe anedi gradually increasing area discharge water discharge cheyadaniki use chestam. Nothing but draft tube. The tube of increasing area is called draft tube. Inward radial flow turbine figure shows that the inward radial flow turbine in which water from the casing enters to stationary guide wheel. Stationary guide wheel ద్వారా water enter అవుతుంది. The guide wheel consists of guide vanes which direct the water enter into the runner which consists of moving blades. Starting లో guide vanes అనేవి you can see here, these are fixed guide vanes, whereas ఇవి moved guide vanes adjust the water inside. Whereas the water moves vanes in the inward radial direction as discharge at the inner diameter of the runner. The outer diameter of runner is inlet and internal diameter is outlet. Whereas outer diameter నుంచి ఇన్లెట్ అవుతుంది వాటర్, ఇన్లెట్ డయామీటర్ నుంచి అవుట్ పోతుంది, బయటకు పోతుంది. సో వీ కాల్ ఇట్ యాజ్ అవుట్లెట్ and inlet. You can see that the top view of the radial flow turbine, whereas side view hub antaru దీన్ని. Whereas we fix the guide vanes, these are fixed one, these are moved plates. Water is flow towards the outlet to inlet and exit this way, whereas these are outlet runner, whereas inlet outer diameter inlet diameter outlet. We call it as, you can see that different diameters, D2 here, D1. The work done per second rho a v1 vw1 u1 plus or minus vw2 u2, whereas velocity of the inlet and outlet is not same, so vw1 u1 plus or minus vw2 u2. In case of Pelton wheel, u1 is equal to u2, so rho a v1 vw1 plus u2. vw1 is velocity of the inlet velocity of inlet outlet, whereas tangent velocity at the inlet pi d1 n by 60, whereas tangent velocity at outlet pi d2 n by 60. N is speed of the turbine, whereas work done per second, you can call it as work done per second per unit weight of the water striking per second. Work done per second nothing but rho q vw1 u1 plus or minus vw2 u2. Water striking per second, water striking enta rho z q, nothing but 1 by z vw1 plus or minus vw2 u2. The equation represents the energy transfer per unit weight to the runner. Energy transfer per unit weight per second to the runner. ఒక సెకండ్కి ఎంత ఎనర్జీ అనేది ఇస్తుంది చెప్పడానికి ఈ క్వశ్చన్ అనేది రిప్రజెంట్ చేస్తుంది. నథింగ్ బట్ 1 by z ఈజ్ ఈక్వల్ టు 1 by z ఇంటూ vw1 u1 ప్లస్ ఆర్ మైనస్ vw2 u2. The equation also known as Euler's equation of hydrodynamic mechanics. Euler's equation of hydrodynamics mechanics. This is also known as fundamental equation of hydrodynamic missions. This equation also given by Swiss scientist L. Euler. In the positive sign is taken when beta is acute angle. If beta is obtuse angle, then negative sign is taken. If beta is equal to 90 degrees, vwt is equal to 0. The work done per second weight of the water striking per second become as half VW1 U1 half VW1 U1. Here it is the case is when you enter in inlet radially but outlet axially, whereas we are getting at 90 degrees, we are entering at some angle but we are exiting at 90 degrees. In this case half VW1 U1 will be taken. Hydraulic efficiency, runner power minus water power. Runner power W by 1000 G VW1 U1 plus or minus VW2 U2, whereas water power W into H by 1000, we cancel it out. If discharge at the radial velocity VW2 is equal to 0, VW1 U1 by GH. Efficiency, hydraulic efficiency VW1 U1 by GH. We can see that the velocity triangle VW1 U1 you can see that VW1 VF1 V1 one triangle, VR2 VF1 VW1 at the inlet triangle outlet, VR2 U2 plus VW2 VF2 V2 at making an angle phi, here making an angle alpha. In radial flow turbine we taken it as 90 degrees, VF2 VR2 V2 will be 0. The following terms in case of reaction radial flow turbine: speed ratio U1 by root 2 GH, flow ratio the ratio of the velocity at VF1 by root 2 GH, discharge of the turbine Q is equal to pi D1 B1 VF1 is equal to pi D2 B2 VF2. In case if they misses 2 or 3 parameters, we can find it out. Pi D1 B1, B means width of the runner at the inlet, D1 diameter of runner at inlet, D2 diameter of the runner at outlet, B2 width of the runner at outlet. So water is flowing at point 2 runner. This blue color one is vanes. Water is flowing inward. Water is flowing inward. Whereas we compare it point 1 and point 2, which is having thickness. Water flows in the circumference area pi into d into width, diameter into width, whereas area of flow at point 1 pi d1 b1, at point 2 pi d2 b2, whereas actual water flow in the circumference area pi d minus nt. In case we taken it, actually these water flows, but we taken it of thickness pi d minus nt into b, water flow in the circumference area, whereas we given a factor k. Discharge Q is equal to area into velocity at 1 VF1 AF1 at 2 AF2 VF2, whereas AF is equal to pi d1 B1, AF2 is equal to pi d2 B2. To get Fi is equal to 0, no radial force on the runner, VF1 is equal to VF2. Fi, in case of no radial force on the runner, radial force అనేది లేకపోతే VF1 is equal to VF2. We can calculate VF1 is equal to VF2. Whereas diameter at point 2 is more than the diameter at point 1 is more than diameter of the point 2. If ఈ satisfy అవ్వాలంటే B1 is less than B2. Width at point 2 అనేది width at point 1 కంటే ఎక్కువ ఉండాలి. If given B1 is equal to B2, then VF1 is not equal to VF2. Nothing, flow at point 1 and point 2 is not same. You can see that blade with the B1 is equal to B2 at width at inlet 1 and inlet out at point 2 width are same, so that flow velocity in direction y is not equal to 0. In case B1 is less than B2, Fy is equal to 0. To avoid the radial force acts on the runner. Radial force అనేది రన్నర్ పైన పడకుండా ఈ డిజైన్ మెయింటైన్ చేస్తాం. B1 is greater than B2. Already we seen that head on the turbine, H is given by P1 by rho g plus V1 square by 2g. Bernoulli's equation. Radial discharge, alpha is equal to 90 degrees, Vf1 is equal to 0. Here outlet velocity d2, Vf2, Vr2, U2, phi. In case of inward radial flow direction has internal and external diameter istadu, d1, d2 istadu. The velocity flow at the runner is constant and equal to 1.5 meter. Determine the discharge through the runner, width of the turbine at the outlet if the turbine is 200 meter per second. Okay, diameter d1 1 meter, d2 0.5 meter, Vf1, Vf2 already they given 1.5 meter per second. Width of the turbine at inlet B1 is equal to 2000. For that we need to find out B2. We know that pi d1 B1 Vf1 is equal to pi d2 B2 Vf2. You can find out the value B2, nothing but 400 meter per mm. Same, they given a data, we need to substitute on formulas. D1 D2 they given 0.9 meters, T2 0.45 meter, N speed 200 rpm, water at inlet B1, velocity of flow Vf1 is equal to V2 1.8 meter per second, guide blade angle alpha is equal to 10 degrees, discharge at outlet radial outlet కాబట్టి beta is equal to 90 degrees, PW is equal to 0. ఈ కండిషన్ మనం గుర్తుపెట్టుకోవాలి. Directly we substitute in values. U1 pi d1 B1 by 60, pi d2 N by 60. Absolute velocity as per this trigonometry, V1 is equal to sin alpha Vf1, whereas V1 is equal to Vf1 by sin alpha. Velocity of the inlet VW1 is equal to V1 into cos alpha. So simple trigonometry, VR1, he applied Pythagoras theorem here. VR1 square minus VR1 square plus VW minus U1 whole square. The runner blade, simple trigonometry, width of the runner at outlet, we already find it out, 400 meter. Mass flow through the runner per second, rho q, and for q you got pi d1 B1 Vf1. Head at the inlet, H is equal to V1 square by 2z. So radial outlet VW1 U1 is U2 is equal to 0. So 1 by z VW1 U1. Total head half VW1 U1 plus V2 square by 2z. Work done per second we already calculated. Rho q VW1 U1, because VW2 U2 is 0. Efficiency VW1 U1 by GH.